Hello guys and welcome back. So today we will again have some very good problems which are very relevant to our JEE Advanced. So basically I was receiving a few comments that I should bring in some questions on binomial theorem and conic sections because yeah, they are like really like binomial theorem is one of those topics which is really trending in JEE Advanced these days. I am telling trending because the hardest question in calculus is from binomial theorem itself, and this year also, previous year also, like binomial theorem is something that is getting really unexpected these days. Okay, like if you have sort of read that chapter, you will know that it's pretty easy. Like whatever we practice and whatever maximum amount of sums we do during our teaching part, like learning part, in that part it's like binomial theorem seems to be the easiest, but JEE Advanced is actually since the past few years giving unexpected shocks. Okay, so yeah, I will bring a question on that maybe in the next video, but today we will have a question on calculus and also a good question on conic sections on parabola. Okay, so you can see this question on the screen. This will be our first question today. And guys, once again, before proceeding, these questions are not made by me. They have been made by the Mathsplorers group. And it's a really commendable work they are doing because these questions are really top notch and absolutely what JEE Advanced level requires. Okay. And I have also attached their Telegram link in the description so you guys can go and check them out. Anyways, that's enough of talk. I guess now we can begin with the questions. So guys, this will be our first question. You can try this question out mainly on the fundamentals. You can try it out. I will wait for a few seconds and then start off with the solving. Okay guys, I guess now it's time for me to solve. So basically, let's give a read to the question first. So there is the parabola y equals to x square, and there are points p0 and p1 which are the origin and 1 comma 1. Okay, so let's write that. Our p0 is 0 comma 0 and our p1 is your 1 comma 1. These are lying on the parabola respectively, and now they are telling that we will have pn plus 1, pn minus 1. Okay, these are points on the parabola such that the line that is passing through the pn plus 1 and pn points is perpendicular to the line passing through pn and pn minus 1. And now if ln denotes the distance in between pn minus 1 and pn, then we have to calculate this limit. So I guess we can try it out, like try to manipulate something with this pn minus 1 and perpendicular, like two lines are perpendicular, so first thing that strikes is the product of slopes being minus 1. Okay, so what we shall do is let's take pn to be, say we are taking some like random variable xn by xn comma xn square. Okay, just anything random. And now what we can do is we can write our pn minus 1 as your x of n minus 1 comma xn minus 1 squared. Okay, now there is one thing given, like if we actually try to find out mn. Okay, mn is basically, what should I describe this as? This is basically your slope in between these 2 points. Okay, mn is the slope in between of the line that is joining or passing through pn and pn minus 1. So this thing will be your xn square minus of xn minus 1 square whole divided by your xn minus of xn minus 1. So this is a square minus b square by a minus b, so mn will be a plus b. Pretty clear? And after this we can actually also find your mn plus 1. Okay, so if you substitute in place of n, you substitute in these 2 points n plus 1, you will get pn plus 1 and pn once again. So basically in that case we will write xn plus 1 whole square. Like I'm not writing that separately because it's a direct substitution we can do in this particular formula only. Minus of xn square whole divided by xn plus 1 minus of xn. So this gives us xn plus of xn plus 1. Okay, so these are the two slopes we are getting, and now we see that these two slopes are like these two lines. One is this line, you can consider it to be line, say it's not given, I will take it as ln, and let's say this line is your L of n plus 1. So what we can tell is your ln into L of n plus 1, this will be equal to minus 1. Why? Because I mean m of ln into m of L n plus 1, this will be equal to minus 1. Why? Because their slopes are perpendicular. Okay guys, I guess I have no space here, so I will change the page and continue. So now what we can do is we can plain simple substitute these two computed values, which are your xn plus of xn minus 1, and this thing is your xn plus 1 plus of xn, and this thing is equal to minus 1. Okay, so now what we actually know from here, okay, like we need to find out some pattern or something, right? Otherwise there will be a lot of unknowns. So what we actually know is our p0 and p1. This is 0 comma 0 and this thing is 1 comma 1. So basically what we actually know is that x0 is equal to 0 and x1 is equal to 1. Like it's a general point, right? I have taken a general point Pn, which is xn comma xn square. So we can put these values and find it out. So what we shall do is let's try to find out a few x's like x2, x3, x4 and so on. We'll try to find them and then we can check whether there is some particular type of sequence coming. Okay. So say we put n equals to 1. So if we put n equals to 1, I guess this is your 1 plus x0 is 0 and this thing is your x2 plus of xn, which is n equal to 1. So 1 equal to minus 1. So I guess your x2 is coming out to be minus 2. Okay. And now if we put our n equals to 2, for n equals to 2, I will calculate this. N equals to 2 is x2 plus x1 times x3 plus x2. Okay, so this is minus 2, 1. Okay, so your, I guess your x3, it comes out to be 3. Let's calculate n equal to 3. I guess we can already notice what will come. But anyways, we will calculate once one term more so that we can be confirmed. For x n equals to 3, I guess this will be x3 plus of x2. This will be x4 plus of x3 and this thing is equal to minus 1. So our x4, this thing comes out to be minus 4. So sequence goes on like 1, sorry, not 1, I should say 0, 1, minus 2, 3, minus 4. Next term will be 5, after that minus 6 and so on. So basically this is actually an alternating sign series. Okay, alternating sign of whole numbers series. Like we can explain like that. So if we try to generalize xn, I guess this will be minus 1 power of n plus 1 times n. Why n plus 1? Because you can see if we start off from 0, the numbers at the odd position starting from 0 are actually getting the minus sign. Like the third position, after that the fifth position. Okay, so this will be our general xn. So having this, our task is pretty easy, but still we have to find out a lot of things. Okay, and guys, one more thing, I guess I had ln was mentioned somewhere else in the question. Okay, so please don't confuse this ln with that ln. That ln was the distance. I know, I just noticed it was present at the end of the question. This ln is actually denoting the line. I should have used some other symbol, but please like handle that. Okay, anyways, now we are required to actually find out the distance between, I guess, Pn and your P of n minus 1. Okay, so let's try to do that. So guys, I hope you remember our Pn and Pn minus 1. Basically our ln, this will turn out to be root under xn minus of xn minus 1 whole square plus of xn square minus of xn minus 1 whole squared, this whole squared, and this is a whole root under. Okay, now here actually lies the main beauty of the question, because like you will wonder, we have unknown quantities, how are we supposed to find these two out? Okay, so basically let's take two cases, because n can be either even or n can be odd. Okay, so let's say we take in our case number 1, we take n to be even, say n is some 2k. Okay, so if we try to find out our xn minus of xn minus 1, this is actually your minus 1 power n plus 1 times n minus of minus 1 power n plus 2, I'm sorry, okay, not 2, n minus 1 in place of this. So minus 1 power n this will be, and n minus 1 means here this will be n minus 1. So guys, if you actually like put n equals to 2k and calculate this, this actually comes out to be your, I guess, minus of 4k minus 1. And now what you can do is you can actually substitute n. So this will be minus of 2n minus 1. Okay. Let's now look at our case number 2. Here our n was even. Now let's take n equal to odd. Some 2k plus 1 say, or you actually don't need to take 2k plus 1 and 2k. I just did this for your understanding because this even, odd, whatever playing we are doing, it's basically because of this power here. Okay. That's the reason we are handling with all these cases. Anyways, if you actually check on your xn minus of xn minus 1 in this part, you will actually get it to be 2n minus 1. Now, very interesting part in this question is that the sign, this minus sign and this plus sign here, they don't actually matter. Why? Because this thing is getting squared. That's the beauty of this question. So I guess that will not at all matter. And now we also need to find this particular quantity. So let's find that. So guys, for finding out this xn square minus of xn minus 1 square, like you can go for other manipulations as well, but what I did this while solving was, we actually know the values, right? x1, x2, x3, and they are pretty small values, so calculation won't actually make a difference. Okay, like few fraction of seconds of work. So I directly calculated that if you find one or two values, you will automatically get this also as 2n minus 1. Okay, like you don't need to prove it. You have the sequence, you have the pattern ready. You find just 1 to 2 terms, you will get it all. Okay, like for the first term it will come out to be 1, I guess. For second term it will come out to be 3 and so on. Like you will get it. Okay, so now I guess we are in a pretty good position to put our values. So ln, this thing will be your 2n minus 1 and another 2n minus 1 squared. So root under of 2 times 2n minus 1 square. So ln will be root 2 times 2n minus 1. This is your final expression for ln. Okay. So now I guess our job is done almost. So we have to find out limit n is tending to infinity ln by, I guess, n. So if we do that, this will be limit of n is tending to infinity root 2 times of 2n minus 1 by n. Now you know that this is minus 1 constant, so n is tending to infinity, it will go on. Only the coefficient of n will be considered. So your answer is 2 root 2. And if you like, this was a numerical type question. So if you want to approximate to decimals, 2 into 1.41, because this year they had given 2 decimal places. So 2.82. This will be your answer to this question. So that was it, guys. I guess this was a good question. You like this? Like, not very difficult, but yeah, pretty sort of manipulative. And like in the exam hall, this might seem a little lengthy, but believe me, if you have like good skills in solving, you have practice, this will be an easy question for you. So anyways, guys, I will proceed on to the next question for today. Okay, so guys, this will be our next question for today, and I told you that I would bring in a calculus question, but I just found out there is some mistake in that question. Okay, like it was from a different source, but there was some mistake in that question, so I immediately discarded that. And although I said a lot that I would bring in, this was the question I was trying to bring out next day. But anyways, let's do this question today itself. Okay, and you can give this an infinite number of stars. Like if you are a really good notes maker, you can keep this question somewhere like pinned in front of your study table and give this 100, 200, like what not number of stars, because this question is a very good question. Okay, this will test everything. Like if you have read binomial theorem only up till JEE mains level, like although there is no mains level nowadays, but anyways, if you have read binomial theorem only up to what our mains syllabus, so-called NTA syllabus permits, then you will not be able to solve this question. But if you have read it till depth, you can try this out, and if you can solve this question successfully, then you are on a really good position. Okay, Please try this question out. Like there will be two different results. Okay, I will give you a little bit hint because this question is really hard. Please like treat the numerator and denominator as two separate questions. Okay, first try to find this out, then try to find this out. Try to find them individually out. They have no relation in between them. There will be individually two values. They will come. These two values will be divided, and then whatever here it is present, you will get that. So use your brains and try to compute these two. Okay, like I will also give you another small hint, just a small hint. I'm not revealing anything right now. For this part, maybe you will make it. You can actually, in this part, this is a binomial question, but I will use a surprise. I will do this using permutations. Okay, like if you have done questions on permutations, like those men, there is a group of men and women. Okay, I will not tell it right now. Just know that I will use permutations to solve. There is also a way to do it using binomial, but that is actually a bit longer. Okay, permutations is bit easy. Anyways, you can try this part out, and for this part you will actually need to use some sort of special series. Okay, like that we have learnt in limits. This much is what I can tell you for the initial hinting, because this is a really good question. You can try the question now. Please take your time, and in case like if you don't succeed in solving this question, don't get disheartened, because I also have done this question about after 2 times trying. Okay, so you don't have to worry. Like this question, you can, what you can do is, if you can solve this question, then you are in a heavenly god level. Okay, like you can be sort of proud of yourself. But if you can't solve this question, please do take inspiration from the methods that I am doing, because such things can be surprises that are maybe waiting for you in the future JEE Advanced. Okay, so it's time, guys. Challenge yourself with this question. Try it out. I will wait for a few seconds. You can pause the video and then I will start solving. Okay, guys, I guess now we can go on into this monster question. So we will treat our numerator and denominator as two separate questions, as I said initially. So what I will do is, I will first try on the denominator and then go to the numerator, because numerator is a bit difficult. Okay, so what we shall do is, we shall first evaluate the denominator, and also what I would do is, denominator is actually something in, like, if any of you have been preparing for IMO and all maths olympiads, IMO or something, then you guys will know this. There is an identity called van der Mode's identity. Okay, this is not directly included in JEE syllabus, but if you are a JEE aspirant and want to remember this, you can, but it is not directly included in your syllabus. Actually, remembering that, you will be able to like directly write the expression for this. Okay, it's a standard expression, but it's not directly like nowhere included in our NCRT and all. It's actually asked in Olympiads IMO. Okay, anyways, so I will write that first. It's actually something of this sort: sigma j equals to 0 to k mcj nck minus j. This thing is equals to m plus n c k. This is the identity I was talking about. Okay, and this identity is called our van der Mode's identity. Like this is, like, I would say this is too high for JEE level. Anyways, if you don't know this identity also, then you should be like, I will not say this is JEE outside. Okay, this is actually solvable. This is actually solvable. Like, it's actually, what I should say, you can regard, when you know the RHS, like if somebody gave you this particular expression and said prove this, okay, prove LHS equal to RHS, then you can first look at this, and then maybe that thing will be bit easier than looking at this directly and trying to prove it. But I will tell you both ways, okay, how to do that. Basically, like, both ways it's the same. Let's take this expression first. Okay, so what I will do is, let's consider, like, I am making an imaginary permutations problem. Okay, like a PNC problem I am making, and from that we will actually show that this thing is equal to this. Okay, say we have like this is something that most of you have done in your basics. Say we have a committee, not a committee, I will not write a committee. Let's say we have a group, a random group of M men, I am writing men as capital M, and N women, I am writing women as capital W. And say we need to form a committee. Okay, we need to form a committee that has K people. So reading this statement, you can automatically understand why I have written this, because RHS is split pretty clearly. Like any person can say this, that reading this question they can for tax say that this thing is the answer. But we don't know this in our exam hall. We know this thing. Okay. So keeping that in mind, why I wrote this. Basically, I wrote this because if you actually observe 1012, like I will not do it here. This is our M. This is our N. Okay. Now 1012 plus 1013, and the summation is also on our 1012. That is a pretty noteworthy point. Like you will have a doubt, like why is this 1012? Try to relate. 1012 is here also, 1012 is here also. Okay, now don't confuse the M. Okay, don't confuse M in this expression with the K in this expression. Just look at my cursor. Don't confuse M here with K here. They are entirely different. Okay, like this 1012 and this 1012 have no relation at all. So what I will do is, basically I took this imaginary expression because I am trying to select J things from M things. Okay. And then I look at this expression and understand that okay, we have a committee which is consisting of say M plus N people. Right? M plus N people. And out of that, I have to select K people. I hope you can try to understand. I'm trying my best. Out of that M plus N people, we have to select K people. Now to select K people, like there will be two categories as I mentioned. I'm trying to frame it in that way. Like men, women is some sort of pairwise the best category that we can consider right away. So what I'm doing is, there is a group of M plus N people. At first I selected M men, say, okay, I am taking an example. I selected M men from this M plus N people. After that, I took the remaining N people and selected them from M plus N. Now, what actually the confusion which arises here is that you will ask me why what is J doing here? So J is actually, I told you from M plus N, right? J is actually the summation of the scenario I explained to you right now. The summation result that it will give us, if we try to verbally write that or verbally say that, it is actually what I spoke out right now. Okay. So better, I will actually change the page and write this in words. Then it will be much easier for you to understand. Okay. So what we can do is, we select J men. Okay. J men can be chosen from M men. The total number of men we have taken it to be small m, right? In our small mcj ways. Pretty evident. And now we need to select the women also, because men plus women will form the committee. Okay, please note that men and women will both be included in the committee. Okay, and it will have at the most K people. Like not at the most, it has to have K people. Exactly. Not at the most, at least not, anything that is not. Okay, exactly K people. So now what we shall do is, after choosing this, then remaining will be like the remaining number of posts for this committee will be K minus J. So that is the number of women we actually require, right? So that we can select from N women in your N C K minus J ways. And now if we actually write this for one particular case, just a minute guys. Yeah. So now this particular thing we have, it's pretty evident these two things will be multiplied, and now we have to like sum it, right? So summing it, I guess this will be your expression that we will get, like what we had written above. And if you actually want to like compare also, this is one way of proving this particular question. And if you want to go the other way, you can say this is m plus nck. Now, one thing that you will ask me is how can we look at this thing and bring out this thing? Like, what level of brainstorming is that? So basically, like harsh truth, but yes, if you do it using permutations, you have to do it like that. Although I guess there can be a method using binomial. I didn't go with binomial actually because I have in my preparation I did questions like this, and men women was actually a pretty famous way to resolve such questions. Okay, you can take inspiration from this if you have not yet done such questions. And using binomial, I have not explored that, but I guess it will be a bit long because this is not really looking good with regard to binomial. Okay, anyways, so this thing our denominator, it's equal to m plus nck. So I guess we can put in the values of m and n as well. So 1012 plus 1013 ck, and k here is 1012. So I guess this thing is actually coming out to be 2025 C1012. So this is it for our denominator. I hope you guys understood. Please, this was a really good method I developed. Okay, please try to look into this. So now we will go on to evaluating the numerator, which is again very brainstorming. This will be exciting for you guys if you are still watching it. Okay, let's go on to the numerator. So I guess let's write this as numerator nr, and I will consider this to be an expression Sn. Okay, why Sn? Because we need to generalize. So this is equal to, okay, so guys, this is our expression, and we haven't like put n equals to 2026 right now because what I wanted was our n equals to 2026 to be put at the end because I want to generalize this. Okay, and now guys, just before proceeding, I would like to tell that this question actually, this part can be actually solved using Stirling numbers and all. Some stuff is there which is not in your syllabus right now. Using that, you can actually solve this pretty easily. Like the method will be shorter than what I am doing right now. Okay, so we are not going into that because it's not in our syllabus. I will strictly stick to our JEE syllabus and solve it. So now what I am actually going to do is like, now there will be pretty lot of number of questions. Okay, I am going to do a rapid number of things now which will generate questions in your mind. But just remember, this is being done because it has to be done, sort of. Okay, like how should I explain? Basically, okay, I will tell you the thing and then I will try to derive a reason. Basically what we are doing is, our standard expression for this thing is actually x minus 1 power n, right? What I am going to do now, I will write this as e power x minus 1 power n. Now this will strike y. So basically because actually if you observe properly in this part, like see, the basic thing is we have to bring this out. Okay, you cannot, this expression has been given in such a way that you cannot rapidly derive it. Like whatever we do, our calculus and binomial, you cannot derive it from any binomial expression. We have to do something and bring it out. So one thing which struck me during solving was that if we try to expand this, because e power x actually the expansion, e power x minus 1, okay, if we write the expansion e power x, it's 1 plus x square by 2 factorial and so on. I bring 1 to this side in the LHS, so e power x minus 1 is equal to x plus x square by 2 factorial plus x cube by 3 factorial and so on. Okay, so basically if we actually do that, we will get a term x power k by k factorial. This will come a number of times in our solving, and this term is actually our trump card. Why? Because if you see carefully, n minus r power n is present alone here. Later on we will actually introduce a dummy variable. Dummy variable, I hope you know what it means. It actually, like, we'll substitute. If you don't know dummy variable, just understand that it's n minus r substituted for something else, and it doesn't affect the sigma as well because we will change the limits here. And then we will have j power n, and in that case, to evaluate j power n, you will actually need this expression. Okay, I hope I couldn't explain it pretty well. I will better on go with the solving. Like, that is what I was actually telling you from the first. Try to take inspiration from this, because this is something new, and even, like, I also was pretty shocked when I found out that this can be solved using this thing. Okay, this is something that you have never seen before. So sigma r equals to 0 to n. This thing is your NCR, like normal binomial expansion. Okay, binomial expansion, the formula we have e power x power r and minus 1 power n minus r. So this thing is sigma r is equal to 0 to n. We take minus 1 power n minus r to this side. Okay, like from here only we are trying to get this thing as soon as possible. NCR. And now we know our e power x, this thing is actually equal to sigma r equals to 0 to infinity x power k by k factorial, right? So we can write this as sigma r equals to 0 to infinity r power k into x power k by k factorial. Okay, this is what we have after putting. So now guys, a little bit of confusion might arise here, that why did I write e power x whole power r as this? Okay, so I will explain it explicitly. What I did was e power x power r can be written as e power rx. And now e power x is this thing, so we can write this as sigma r equals to 0 to infinity. In place of x power k, we substitute r x power k by k factorial. And now actually r power k has nothing to do with this, so we pull it out. Sigma r equals to 0 to infinity. We can write this separately, or rather we can pull it out also. Anyways, like, not directly pull it. Okay, it's x power k by k factorial. So yeah, it's r power k has nothing to do with this. But anyways, we are writing it within the sigma because here there is a dependence. So r power k into x power k by k factorial. I hope it's clear now. So I will change the page. I have no space here. So let's sort of rearrange this thing. Okay, I am bringing the sigma infinity outside. Like, if you have heard, like, studied the properties of sigma, you know that infinity sigma can be always brought to the exterior part. Like, the outside most sigma can be tending to infinity. Okay, sigma r equals to 0 to n minus 1 power of n minus r ncr r power k, and outside I am keeping r x power k by k factorial. So as I mentioned in the beginning of our question, x power k by k factorial is something which is really beneficial to us. Now, if you actually observe properly, in this expansion, like, this was equal to our e power x minus 1 whole power n, right? So in this particular expansion of e power x minus 1 whole power n, the coefficient of the term x power k by k factorial, where k can be anything in between your 0 to infinity, the coefficient of any x power k by k factorial will actually be this thing. That is why I wrote this like this. Okay, I will write this also, coefficient of x powered k by k factorial, it will be equal to this. That was the reason behind why I wrote it like this. Okay, I hope this was Clear. So now I guess we can rewrite Sn once. So I am going into that. I'm changing the page. So actually, okay, Sn is not still proved. So what we can do is I am writing this thing as Tn. Okay. So Tn is our sigma, or rather write it as Cn because it's a coefficient. Better. This is your, okay, Cn is another problem because it's inside. Okay, Tn only. Why am I messing so much with the representation? Anyways, this is sigma j equals to 0 to n minus 1 powered n minus j n c n minus j and j power n. Okay. Okay, so guys, I actually cancelled this part because there was this r, so I wrote it as j power n. Actually, I should have written it as r, but that r power n factor would actually confuse you, like how did I bring it? Okay, so for that I'm writing one extra step. That's why I cancelled and did all this rubbish. Basically, I am writing this as x power n by n factorial. This is a way of representing. Okay, just I don't know whether this is very formal way of representing. Anyways, just a way of representing. And I will write e power x minus 1 power n. Basically, coefficient of x power n by n factorial in e power x minus 1 power n. Now, in the earlier expression, we had come about the coefficient of x power k by k factorial, right? So what I am doing is I am setting k equals to n. Why? Because we want the coefficient of x power n by n factorial actually. Okay, we will need that. So I am putting k equals to n here. So this thing will become sigma r equals to 0 to n minus 1 power of n minus r n c r power n. Okay. Now from this particular part I have to explain something to you which is pretty important. And before doing that, one more thing we will also do. To bring this into the form that is given in our question, I will put k as your n minus r. Okay, you will understand why. So basically this thing will become sigma k equals to 0 to n. I guess the limits will be like this. And this will be your minus 1 power n minus, I guess, k. And this thing will be n c n minus k and k power n. So we can write this as sigma k equals to 0 to n. I guess this thing will be minus 1 power n minus k and n c k power n. I just wrote it in terms of k. Okay. Actually, no significant change. I thought it would look something different. Anyways. Okay, if there is no significant change, actually, I have to then go on into the e power x minus 1 expansion part. Okay. Now, this part actually needs a bit of explanation. So, like, put it on hold up till this and consider that this is your coefficient of x power n by n factorial. Now I am going changing the page, I am going downwards, and now I will explain to you something important, because this x power n is actually, like, what should I say, it is the only barrier that is present between us and the answer right now. Okay, so we need to do something with this x power n. So I am changing the page and explaining to you what to do. So basically our e power x minus 1 whole power n, this will be, if we want to expand it using our expansion, this will be x plus of x square by 2 factorial plus of your x cubed by 3 factorial, and this thing is up till infinity whole power n, right? Now notice one thing, this is actually e power, like this expression you can write it in n number of brackets one after the other, right? And these n number of brackets actually make that power n. Pretty clear. And now, one thing which I would like to tell here, listen to me carefully, okay? When we expand this particular thing, then any term, okay, any term which is in the form x power m by m factorial, like except that x power one thing, and any term in this expansion will be of this form, right? So, and here where m is greater than 1, obviously, if this term is chosen for any of the n factors in this product, meaning that if we take any like such a term from any of the n factors, we can take it from here, we can take it from here, here, any of these factors, from there we take this term, okay, any one term, then for that the result will be in the power of x, but it will have a power which is greater than n. I hope this was clear. Like for example, say I am taking an example, say I take x square by 2 factorial, the right next term, okay. So what this will be? This will be x power of n minus 1. Now listen carefully why I have written this, okay. There is a lot of explanation in this part, so please listen carefully. Actually, what we are trying to do is we are taking n such brackets, each containing the same expansion, this thing x plus x square by 2 factorial plus whatever, and we are selecting specific terms from each of these brackets, and we are selecting these terms in such a way such that this expansion and the coefficient which has been produced by us right now, it has minimum effect. I hope this was clear, okay. So what I did was I took x from n minus 1 brackets. Like say if these are the n minus 1 brackets, from each of these brackets I took x. Okay. And for taking the bare minimum case and checking what sort of a change it can take, I am just taking from one single bracket that x square by 2 factorial term. I hope this was clear. Basically, I am taking just one bracket, from there I am taking x square by 2 factorial, because like the maximum case that can occur is which will actually have the bare minimum change is that we take x's from all the brackets, right? But we need to have a reasoning, like why will we do that? We need to have a reasoning for that. So that is what I am trying to explain. I am taking the bare minimum change and bare minimum term also that can cause the change right after x, which is x square by 2 factorial. And we are taking that as an example and trying to find, okay. So if we multiply x power n minus 1 from all these brackets and x square by 2 factorial. So if we take this coefficient, it actually comes out to be x power of n plus 1 by 2 factorial. Now you can see the power is greater than n, right? And now this power being greater than n, we will not be actually able to bring out our x power n. Motive of all this was we need our x power n by n factorial, right? Because see, actually if I try to speak this in a broader sense, what we are trying to do is our main aim is to bring out that numerator in our once upon a time old question that we were solving about, I guess, 10 to 15 minutes ago. That is our main aim. Now that complete expression has come on one side, and that is multiplied by 1 x power n by n factorial, which we don't need at all. It is like, what should I say? It is like a balloon that is attached in your birthday party and you don't need it right now. Your birthday has passed 3 months away. You will not keep a balloon like that, right? You will either burst it or throw it away in the dustbin. So we don't need this part, and that's why I'm trying to eliminate it, okay. So if we actually take even one term from any one of these n brackets, the bare minimum case, then also you can see that the power is getting greater than n. It is becoming n plus 1. So there is no other option actually than to take x from all the n brackets. All the n brackets we have to take x from this expansion. So x power n is the only, like this is the only case where we can obtain our x power n, okay. And now this particular thing, what will be the coefficient of x power n here, right? Now we are taking x from each of these brackets, and coefficient of x is 1, so coefficient of x power n will also be 1. I hope this was clear, okay. Coefficient of x power n will also be 1. Like this is sort of, I am approximating, because x square by 2, x cube by 3, like if you multiply anything and everything, a sum which is going towards infinity, this thing, like if you have heard this term converging, this thing will actually converge to a point where at infinity it will, or approximately like very it will tend to 0. It will go very close to 0, okay. It will tend towards 0. So in that case, we need to, like, our target is x power n. So all this testing was actually done to find out whether there can be any other case than this where our x power n can be obtained or not. But taking the bare minimum also, we found that it is a power which is greater than n, and if that happens, it will affect the whole work that we did right now. It will affect our purpose basically. So now if coefficient of x power n by n x power n, I'm sorry, it is equal to 1. So we write little back, we found something like this, that sigma j equals to 0 to n minus 1 power of n minus j n c j j power n. I'm writing it as j, okay. I hope I wrote it as r there. I'm writing it for the time being as j. Actually that j I wrote was supposed to be written here. I accidentally wrote that before. So this was our thing, and x power n by n factorial. Now we are talking about coefficients. So x power n by n factorial, x power n already has a coefficient 1 by n factorial, right? And now this particular thing has a coefficient equal to 1. How? So actually for explaining this, I have to do another small derivation, okay? Like this thing is actually not like this one, okay? Only this single question has led me to yet another derivation. Anyways, I will do it. This is actually not directly in your syllabus, so you don't need to know the name. Just listen to what I am saying, okay? I am changing the page and doing it. So basically that thing which is written there, I told that this thing, this complete that bracket part, all those sigma, figma and all, divided by n factorial, this thing is equal to 1. Actually, this is your e power x minus 1 by n factorial. This thing, in this thing, coefficient of x power n by n factorial, this thing is always equal to 1. And if you want to know the name, don't go beyond your syllabus. Just for your knowledge, if you want to know the name, this is actually called Sn comma n. Okay, this is something called Stirling numbers, but please don't go in deep into this. This is outside your JEE syllabus. I'm just telling you just a small introduction. Basically this kind of a thing is the number of ways to partition a set of n elements into n non-empty subsets. Okay, this actually is the meaning of Stirling number. Now not Stirling number, there is much more into Stirling number. Just for the time being, you remember Sn comma n means this. Okay, now this doesn't mean actually this. Sn comma n is actually that sigma expression we wrote above in the bracket. Okay, so basically that thing is your coefficient of x power n by n factorial, which is actually coming out to be 1. I hope now this was clear. And now if you see this particular definition, now I hope this is easier for you to understand. This definition actually means that there can be one way only, because n elements into n non-empty subsets, there will be only one way. Why? Because each element will be placed into its own separate subset, right? I hope this was clear. I had to like trudge a little bit out of your syllabus, and I like, you don't need to remember all this. I had to little bit trudge out of your syllabus because that part was getting really messed up. Okay, I hope this was clearer to you. So this is it guys, and now if we look into this, our standard expression for which we were fighting so long with n equals to 2026 is finally ready. And if we actually put n factorial to this side, our answer for this thing is nothing but n factorial. So to derive this n factorial, we did so much of war. Anyways, this was like, this question solving whatever I did now, this will be a good experience for you, because you don't need to remember Stirling numbers and anything. I'm telling you repeatedly, okay? Please don't go into like researching about this on Google and anything, because this will blow up your mind. This is not in your JEE syllabus. This is for IMO people who are preparing for Olympiads, okay? Don't go into confusing yourself. So I guess our sigma r equals to 0 to 2026. I will write our original expression now, minus 1 power r, because r is basically your n minus j which was put above. Okay, if you notice, actually I substituted r equals to n minus j there, so you can like replace it with r itself, 2026 cr, and this thing is your 2026 minus r power 2026. Why? Once again, please remember, there I substituted j as, I'm sorry, not j, I should write, in that step I substituted r as n minus j. Okay, so n minus r actually becomes j here. I should have written that before, I'm sorry. So this thing comes out to be n factorial, which is 2026, I guess, factorial. So here are numerators and denominators. Guys, this was a bit difficult, I know that. I have tried my best to explain it. I hope you guys could understand. Still, if you have any problems, please write out to me. I will be like, maybe I will try to bring in a better explanation, because this thing was very, very difficult for me to solve. Okay, I am trying my best to explain this part. Anyways, so we have our numerator and denominator ready. So I guess now we can just evaluate the expression and find out the answer quickly. So this thing quickly becomes 2026 factorial whole divided by your 2025 C1012. So I can write this as, now you can just do normal factorial breaking, 2025 factorial, and whole divided by whatever step is there, it will go on to the numerator. 1012 factorial will be there, and I guess 10 subtracting 13 factorial will be there. So 2026 can be factorial can be written as 2026 into 2025 factorial. So we can cancel this thing like this. Okay, that's what I do actually, shortcut type of. So 2026 into 1012 factorial into 1013 factorial, which is a b factorial c factorial. So a, b and c, our values are here. So a plus b plus c, 2026 plus of 1012 plus of 1013. I guess 2026 plus of 2025. So this thing comes out to be 4. 1 plus, I guess 6 plus 5 is 11. So 4051. This will be the answer for our monster question. So guys, I will just scroll and show you whatever we did right now. You can see the whole lot of stuff we did. Okay. So it's pretty complicated. Like, I myself admit this question is very tough for you guys. Okay. But anyways, our final answer is 4051. And guys, I hope, like, even if maybe I don't know how well my explanation was, but at least you guys could take in something from this question, because not being able to solve a question during preparation is not the main thing. Whatever intake you are taking in from that question, not being able to solve, that is actually the main thing that will help you in the exam hall, because anything can come, right? So I hope my explanation could do something of that. Anyways, guys, 2 questions are done for today, so I guess we can end this video here. So if you like my content, please do like, share and subscribe, because that's what keeps me going. And I will bring such videos also in the future. I will keep bringing on. And I also had a plan of bringing in a video on underrated JEE mains questions. Okay, because JEE mains PYQs contain literally some real gems which are hidden in front of public. Okay, nobody like sees them with the real eyes. So it's my duty to bring them into the limelight. So I guess I will bring that video very soon in future. And that's it for today, guys. Any recommendations, please drop your comments down in the comment section. So that's it for today, guys. Thanks for watching.